blockhead, so we don't want. All the pieces of the puzzle, logarithmic expressions. The student works 1, 2, 3, and 4. Let's take a look at the next page. Getting started, two-way street. Recall that a logarithmic function is the inverse of an exponential function. 1. Write the equivalent form of a given exponential or logarithmic equation. All right, go ahead and complete the table. Let's take a look at the next page. Activity 1.1, solving of logarithmic equations. When you evaluate a logarithmic expression, logarithm, you are determining the value of the exponent in the corresponding exponential expression. The variable of the logarithmic equation have the same restrictions as the corresponding variables of the exponential equation. The base b must be greater than 0 but not equal to 1. The argument must be greater than 0 and the value of the exponent has no restrictions. It is important to become familiar with how the base, argument, and the exponent fit into a logarithmic equation. A logarithmic equation is an equation that contains a logarithm. 1. Arrange the given terms to create a true logarithmic equation. 1a, 49, 2, and 7 can be used to create log base 7 of 49 equals 2, or 7 squared equals 49. 1b, given negative 3, 6, and 1 divided by 216, you can write log base 6 of 1 divided by 216 equals negative 3, or 6 to the negative 3 equals 1 divided by 216. 1c, given 4, 4, and 1, you can write log base 4 of 4 equals 1, or 4 to the 1 equals 4. 1d, given 256, 4, and 4, you can write log base 4 of 256 equals 4, or 4 to the 4 equals 256. All right, let's take a look at the next page. Let's consider the relationship between the base, argument, and the exponent. You can use the relationship to solve for any unknown in a logarithmic equation. Go ahead and write down or read over the worked example. All right, go ahead and mark out 2A, B, and C. Let's take a look at the next page. 3. Solve for the unknown in each logarithmic equation. A. Log base 8 of 64 equals n. We can actually use Desmos to calculate that. So we're going to go to Graphing Calculator. Here, we're going to go to Functions. I'm going to scroll down and then back up. So n equals 2. Now, b, you can rewrite that as n to the negative 2 equals 1 divided by 16. And we can use Desmos to solve that. So we're going to graph. We have to change n to x. X equals x to the negative 2. And y equals 1 divided by 16. Now, you're looking for the point of intersection, and you only want the positive point, which in this case is 4. So n equals 4. All right, let's take a look at C. Log base 1/2 of 64 equals n. We can just use our calculator for that. So function base 1 divided by 2 of 64, n equals negative 6. All right, let's take a look at D. So then I can rewrite that as 10 to the negative 3 equals n, which can be rewritten as 1 divided by 10 cubed equals n, which we can also write that as 1 divided by 10 cubed as 0.001. So n is equivalent to 1 divided by 10 cubed, or 0.001. Let's take a look at E. So then we can write that as n to the 2/3 equals the cube root of 49. We can use Desmos to solve that. So we're going to go to x to the 2/3, and then function, scroll all the way down. Now we actually have to put y equals cube of 49, and Let's press the home screen, zoom out. We only want the positive point of intersection, so that's 7. N equals 7. Okay, F we can just plug into our calculator. So function log base 9 of 27 is 1.5. Okay. Now we can actually do G, H, I, and J all in the calculator. So let's go and do all of those together. So function log base 5 of 625 is 4. Function All right, go and finish up G, H, I, and J. All right, let's take a look at the next page. Activity 1.2, estimating with logarithms. A logarithm is an exponent, so it can be any real number, even an irrational number. 1. Label each number line using logarithmic expression with the indicated base. All right, go ahead and complete that. All right. 2. Compare the logarithm on the number lines. A. Analyze all logarithms that are equivalent to 0. Write a general statement using the base b to represent this relationship. The logarithms that are equivalent to 0 all have an argument of 1 regardless of the base. Therefore, log base b of 1 equals 0 for b greater than 0 and b not equal to 1. B. Analyze all logarithms that are equivalent to 1. Write a general statement using the base b to represent this relationship. The logarithms that are equivalent to 1 all have an argument that is equal to the base. Therefore, log base b of b equals 1 for b greater than 0 and b not equal to 1. All right, let's take a look at the next page. C. Rewrite the general statement from parts A and B in exponential form. Use exponent rules to verify that each statement is true. The logarithmic equation log base b of 1 equals 0 can be rewritten as an exponential form as b to the 0 equals 1. The logarithmic equation b log base b of b equals 1 can be rewritten in exponential form as b to the 1 equals b. You can estimate the value of a logarithm that is not an integer using a number line as a guide. Go ahead and read over the worked example. All right, let's take a look at the next page. 3. Sutton and Silas were each asked to estimate log base 4 of 28. Go and look over Sutton's work, Silas's work. Silas did not use a number line, but his estimate was about the same as Sutton's. Will Silas's method always work? The method Silas used will always work because he is using the definition of a logarithm when making his estimate. 4. Estimate the logarithm to the nearest tenth and explain the reason. Okay, let's go ahead and do A, B, C, and D. All right, we're going to finish up 4A, B, C, and D. All right, let's take a look at the next page. Go ahead and mark out this page. 6. Approximate base of each logarithm. Okay. So this can be rewritten as b to the 2.9 equal to 108. I'm making graph to find the value of b. So let's go ahead and do that. We're going to use x instead of b. So x to the 2.9 y equals 108. Now you're going to have to zoom out so you see the point of intersection. Ta-da, there it is. Now you want to zoom back in. Make sure you don't click on the y-intercept, but the point of intersection, which is okay. So b is approximately 5.0. Let's look at b. Okay, that can be written as b to the negative 1.3 equals 0.4. All right, I'm going to press the home screen, exit out of here. All right, and then there's our point of intersection. Okay, b is approximately 2.0. Let's take a look at c. C can be written as b to the 3.1 equals 74. Okay, so you can zoom out till we see the point of intersection, and then zoom back in. Right, b is approximately 4.0. All right, go and finish it up and have a wonderful Wildcat day.